For me, secure code audit is rather an art than algorithmic process. And in today's workshop, I'm going to go through a number of techniques that we can use to identify rather silent or overlooked bugs by a typical security scanning tool. So if you're a software engineer, this workshop will be useful for you to identify those rare edge cases that could lead to a security bugs. You can identify them early on, or if you're a security professional or penetration tester, it will help you to identify quite many different classes of security bugs that you can find and report on when you do white box security assessment. So let's get started by looking at the code for this workshop. Now, we are going to head to play.secteam.com. This is a portal that we're going to use throughout this workshop. So first thing, hit on sign in. If you don't have a user account, you can create one now. Otherwise, you can log in using your existing user account. Sign in. Now, once we are back here, if this is the first time that you are using this Play platform, you want to make sure that you have added your SSH key, because we need the SSH key to access the code. So click on this, let me hide my, my view here. Click on this icon here and hit on Secteam ID. This will open up a new tab, and in this tab what we are going to do is we are going to log in again and add a SSH key. Yep. And over here you hit on SSH key, and right here add or update SSH key, and similar to many other SSH keys that you have done before, you can add one here. One thing to remember, let me head to terminal now. When you generate, you can generate obviously a new SSH key or reuse one of the previous one. Anytime you generate a SSH key, if you keep using this file name, ID underline RSA, this is a default file name that will be used when your SSH or Git client tries to communicate with any new server. So either you keep the same file name when you generate this SSH key, or you can obviously create a new file name. But there just could be a further configuration process you need to do to make sure your Git client uses the right SSH key to communicate with the server. So I've already done this. Now to verify if you can access the website, what you can do is you can try this command, ssh-t git@game.secteam.com, and what we expect to see a welcome message with your username right here. All right, if that's all done, let's head back to the browser and go back to play.secteam.com here. Let's scroll down to Go, and over here head to Confusable. This is a lab that we will be working on, and this is effectively a challenge, and this challenge is an intentionally vulnerable program. That the goal of this challenge is we firstly do a code audit, find a security bug, and later we fix it. So head toward the bottom, find the play button there, hit on play, and this will, once you start hitting this button, a timer will start, and we will be given a private fork repository of this lab. Let's copy that, head back to the terminal, and what we're going to do is just simply git clone that URL, which I have already done it. We just cd to that URL, and like our previous labs, the first thing we will do, we want to run this program just to get a feel what does this program does. So make build, this will build this lab for us. And if we run make run, it's going to run that Go program. So the program asks us to enter a domain name. Let's just give it a domain name, let's say such as secdim.com. Domain already exists, try another one. Let's run it again. And this time let's give it a different domain name, example.com. Domain is successfully added for registration. So it's very simple and basic program. The other thing we can always do is to run usability test. Again, make test. This will run the functionality or usability test for us. And as we can see, there are 2 tests that was executed and all got passed. All right, now we have a bit of feel about what this program does. Let's just dig into the code. There are a Docker file, a make file, and a README guide. We can ignore them for now. We can find the actual code for this inside the source directory. Like any typical Go program, it has the main file, files that are suffixed with test, which refers to our tests that are being executed, and obviously the Go mod and Go sum. These are the files effectively that define the dependencies that are used by this program. So one of the first things we should always do when we open a new code, and this code is intentionally pretty simple, is to look at the dependencies. Because obviously if there is anything missed, or if there is any dependency there that is outdated, we can simply call it out and find it out. So one thing when it comes to the dependencies, this is not specific to Go, it could be in any other language, is that we have some direct dependencies. Things that are directly used by the program. But those dependencies could be dependent on other dependencies, and those other dependencies could be dependent on other dependencies as well. So these we refer to them as indirect dependencies. As long as we keep our direct dependencies fully up to date and patched, it's a good practice to do, and that's something that we're going to check here. But regarding to the indirect dependencies, that is something that normally the team and the people who are maintaining that package, obviously they need to go and update them. So a rule of thumb will be the less dependencies that we have, the less reliance we have on, from a security perspective, on others' code, and it's more controllable for us. But obviously in today's wars, as the programs are mostly assembled than being written, we can't get rid of those insecure indirect dependencies. Now in our case, we can see one of the, well, these are some of the dependencies that directly used and some of them not directly used by the code. Either we can look at what the dependency is, and we can go and look it up. If this version is the latest version, we can look at the change logs of that. Has there been any security bugs been patched since this version, things like that. Or obviously we also have some tools that we can run to perform a dependency scanning. Now, in regards to Go, one of the tools that we can use is called Dependency Check, which is from OWASP. This tool historically was used for, let me open up and show this tool to you. So Dependency Check. And this tool is, let me move to my terminal, my browser. So Dependency Check is a tool by OWASP. Now this tool historically, as I mentioned, was used for scanning a lot of Java enterprise code. And there is also an experimental feature added to this tool for Go dependencies. Now the complexity of any dependency scanning tool that we use is those indirect dependencies, and how depth these tools have a database, and how depth they can go to identify all the issues or vulnerabilities with those indirect dependencies. And so far, at the time of I'm recording this dependency check has an experimental feature for Golang. So we can find a Docker image for this dependency code. So just type in docker.pool OWASP dependency check. And this hopefully gonna go and download the latest version of this dependency check for us. And then we can run that against the code that we just downloaded. So docker run /rm. I'm going to mount the source directory from the host to the container. So dependency check. Now I need to give it a flag enable experimental, followed by scan, and followed by src. So if this is first time you're running this, you will see that dependency check first will go and fetch all the issue libraries or CVEs that was reported since since the year 2002. So this is gonna take a while to download all those issue libraries, all the things that are being reported. As I said, this tool is not specific for Go, it's for Java as well. So there's quite a lot of things it's gonna first to download. And then once it did, it will go and scan that Go mod file. Now for this, I will leave this terminal open here. I'll move to another terminal, and which we are going to run another tool. Let me open that up. Just move this one here for now. Just head to the browser for now. And once this download is finished, I will come back to this terminal later. Okay. So let me move to this other terminal that I have. And share that with you. Okay. The other thing we can do is to run a SAS tool, and these are the tools that are known as a static analysis tool, where they look at the content of the file and they test the file against a number of rule set for common insecure coding patterns. For example, if there is a usage of a specific function that this function is not safe, or if there is a specific coding construct that is not safe, these tools may or may not have a rule for that, and we can use it to, for me, effectively find some low-hanging fruit, type of security issues that or security bugs that are super obvious, and these tools could be useful to find them out. Now, the space of these tools are quite many. We have open source tools, we have commercial tools, we have some tools that promising some machine learning and AI in it, but overall it boils down to a number of rules, the quality of the rules that these tools that they have. Whether or not, now for now I'm going to use one of these tools which is known as semgrep. There is also for Go specifically, we have a tool called GoSec. But again, both tools are running rules. So let me open up semgrep for. So I'm like the OWASP dependency checker. I'm gonna fetch the semgrep Docker file and run it against our code. And simply by running a command, this command, I can run semgrep. And as I said, semgrep comes with some preset tools, the rule set. And for example, this is a rule set that I'm going to be using. This rule set is, well, if you, for example, search for Go, this rule set is has a number of rules that are there, and it's called by R2C. So we can use this package to scan for these tools, so these rules. So let's go back to the terminal. And I'm gonna this time run this return to corp, I think was return to corp / semgrep. Just test it out if I got it correctly. Yeah. And semgrep -- config, and here we specify our rules that we're gonna run against this code that we have. So there's a typo here. Let me fix this up. So it fetched the rules from the registry, and it's gonna run it against the code that we have. And if there is anything, as we could see, well, there is nothing being reported. The program is pretty minimal, so it seems it does not have any obvious security problem. All right, now is the time that we get our hands dirty. Let's open up the main file and see what does this program actually do. Very simple, only 36 lines. And starting from the top, there is an array that contains a number of, well, domain names that I would say this could be those domain names that the program does not want us to re-register. Following with the main function, which prompts the enter a domain name, and it will go through, take that value from the command line, and it will pass it to a function called register. And if this function returns through, it will say domain is successfully added for registration, otherwise domain is already exist. Now looking at this register function, we can see there is another function being called contain. This is passed in these domains, which is this array on the top, following with the input that is received from the user. And it will return false or true depending on the result of this function. Okay, and heading down here, and there's something interesting comes up. As a contains function, this will go through whatever is being given as an input, and it will take that domains as an array and the input, and it will loop through that array, and it will check if that input, the input that the user has entered, well, that parameter exists in that array. If so, it will return true, otherwise return false. So in a first look, nothing really becomes super obvious here that there could be an issue here, specifically on line 31, when there is when we do a string matching. And this is something that in this code, it is intentionally written super simple to highlight this problem. That are we here, when we comparing these two values, a and str, are we comparing two things in the same format, in the same context, or effectively, as in English we say, are we comparing apple with bananas? Now, you may find that in a lot of cases that when we do string matching, we don't really consider the context in which these two values are being in before we perform the string matching. So what do I mean by that? So if we now think a little bit deeper about what this app is trying to do, is effectively wants to avoid someone to go and re-register some of these domain names, which has already, let's say, registered in the system. Now, from a syntactic perspective, I wouldn't be able to re-register a domain called paypal.com because it's already there, or secteam.com. But there is but from a usability perspective or from a user perspective, what if I would be able to register something that look a little bit similar to one of these domain names? Are we catering for all of those cases? Now, if you have seen one of our previous workshops, which I went in depth talking about the history of Unicode, ASCII, and all the code pages, most likely you already have some ideas that although we are doing good string matching here, we are not catering for many, well, inputs that could resemble, or many inputs that could resemble, or domain names that could resemble like a PayPal or one of these registered domains. But our string matching algorithm will not detect those and simply will allow someone to re-register. So from a user perspective, an end user perspective, that domain looks like one of these, but so it could be one of these, but from a code perspective, there are two different things, and hence it will allow this unauthorized addition of this content. So one of perhaps the simplest thing we can do is, if we want to do some runtime analysis, you just test for one of those. The simplest thing is that string matching was just effectively doing a dump comparison of the value that is given. What if instead of PayPal or SecTeam, I enter SecTeam like that with a bit of case folding? Well, that could pass through this code. So rather than here, I start adding all these, different edge cases that could result to a potentially bug, but in this case, a security bug. I want to talk about a better way that we can formulate these edge cases or these inputs, and it will be shipped, and it will be always with the app, and later on we can use them to pass this test, and anyone else also in the team can use it. It could be part of a CI/CD. So it's effectively so we're going to talk about the way we can add these inputs rather than ad hoc inputs that typically as a pen tester we may add to the program. We kind of formulate them and kind of put them in as a set of security tests. Now, one thing before I mentioned, I did run make test, which this ran the functionality test against the code. The other thing we can do, we can run make security test, and this will run those classes of the security unit test against the code. Now, as we can see, there are two tests here. One of them both of them are failing. One of them is called fix me. Let's open this up and see what is inside this. And you can see one of them is effectively testing a lookalike domain. So effectively, can I register something using this? What about this, which perhaps look like SecTeam, but it's using two different characters? Again, I refer you to our previous workshop about all the variety of someone can be able to enter a lookalike, and following with this test that is asking us to complete it. So maybe let's move here, and I'm gonna start completing this test. The first thing is effectively what I've just done. I want to test for that case where a test is a case fold situation. So test case fold, and over here, what I'm gonna do is I'm gonna give it let me get rid of this. Effectively, I'm gonna put something similar to this here and start formulating them. So just say paypal.com. So I expect, when I pass paypal.com to the register function, I expect to receive a through. So sorry, that means that domain should not be able, user should not be able to register that domain, or something like maybe secting.com. That should not be there. Make build. And now we can run our security test, and it's gonna fail. So that is our first set of failure test. Okay, so there is an issue here. I need to fix this up. All right, so I cannot double declare this variable as expected. Make build and make security test. You don't need to run everything in Docker. You can open this up in your Visual Studio Code and start coding there as long as you have the dependencies for this program. But for now, for portability purposes, I just run everything in the test. So as we expect, our test also failing. Now, is there any only way that someone can enter something and bypass those checks? Obviously not. Now, this will take us to the interesting part where we're gonna look at what is known as a Unicode confusable characters. Again, we talked in length about those problems. We can try some of those confusable characters. Let's just call them test Unicode confusable and start testing T. All right, what about that? I want a similar construct, but what will be my input here? Now, if we go back to a browser, just to give you some idea around where we can find some of these Unicode, there is a Unicode confusable tool from Unicode that we can enter any input here, and it gives us the list of characters that look similar to some of these characters that we have picked. So let's say if I enter P, it will give me in the first column here, it will give me all the P's written in Latin, following with a similar P, but from a different language. And obviously there are so many other variety of that. So you can effectively pick any of them and use it as your as a tool to test for this confusable in the code. So let me pick, and as you may know, each of these characters come with a code point. You can either use a code point that is more recommended than copying the character itself. All right, so let me pick one of them here. Well, we can pick any of them and adding it to the terminal. So I've already picked a few of them. You can either, as I said, you can either copy the character or you can just enter the code point like as follows. We are also expect that if this sample Unicode confusable was given to the code, also this should not be allowed to be registered. So let's just make build again. Make security test. And we should see our 3 tests are failing. Perfect. So now, nicely, we have all those security edge cases or bugs now formulated as a unit test. So the next step will be to let's go back to our code and fix those issues. So our test will be passed. Now, one of the there were 3 techniques we talked previously that we can use to address Unicode confusables and these type of bug classes. Now, out of those 3, the most recommended and the safest way for us to address this confusable problem was to limit the char set to ASCII. So if we are working in a context where having Unicode characters are not even expected, the safest way to address this issue is just limit the char set to ASCII, and this will shrink down the possibility of those many confusable characters that a user may be able to use. And this is primarily the approach I'm going to use here. I'm going to shrink it down because in the context of the domain, in the context of this code, well, ASCII could be a good choice forward. Obviously, in the context of a different app, let's say a discussion board or a commenting app, where we do expect for a usability perspective that user will enter Unicode characters, we can't be as strict. But in this context, and we need to use different techniques there, hopefully in some of the future workshop we talk about them. But in this context, let's just be quite strict and limit the cursor to ASCII. So, and one of the other things I'm going to use is I'm not going to use any random library or dependencies. I'm effectively going to go with the Go official modules here. So there are two libraries I'm going to use here. One is called strings to do some string matching, and the other one is Unicode UTF-8. This library will help me, this official library will help me to identify if there is any Unicode characters, specific code points within the input string. Now, before I continue on, I will open also the security test just to see what I'm doing here. Now, for these two other cases that I have here, I'm just simply will add them as some of the possible values. So I will add this as one of the lookalikes, as is ASCII. So I can't do much about that. So let me add this one as one of the possible values. So that will prevent that test for me, and I increase this to 4. And the other thing I'm going to do here is I'm going to introduce a new function. Now this function, what it will do is, now I'm going to create one function that before this string matching happens, it first normalizes the code, so get rid of those random inputs that they may enter, and once that is happened, then I will do my string matching. So let's call this normalize, and in this function I'm gonna get one input, let's say unsafe domain, it's a string, and this function gonna do two things for me. I'm gonna first check if this input contains Unicode. If so, it will need to return an error. Otherwise, it will return the actual value back to me. So two things. So I'm gonna get a return of a string and Boolean. Obviously, there are many other ways you can code this. This is just one sample. All right, let's just define one local variable here. And now what I want to do, I want to loop through this input that was given to us, and I want to go character by character, look at the way, use that library UTF-8 and decode every character and try to identify the code point. So now what I'm gonna have is the size of that character. Again, some Unicode character may have a more than length of 1, depending on a code point. And what this function gonna give back to me is the code point for that character. Now, why it's matter to me is that if this code point is bigger than 127, and again, you can refer to our previous workshop on Unicode, this means that it contains a non-ASCII character, and therefore I want to reject it. So that means I'm going to return through as an error and an empty string back. Otherwise, I just need to complete this loop domain, and then I just need to shift one character ahead to scan for the next character in that input. Yep. All right. So now if everything is all good, well, so that means that once this loop went through it didn't identify any non-ASCII Unicode characters, so I can simply return. But before I return, if you remember, I want to also cater for that case folding situation. I want to normalize everything, or make everything to the lower cases, so I don't end up having a domain that, because of the case folding, it could bypass my check. So I just simply do 2 lower here and unsafe, and also I will return false. So let's just review this code again. So we get a normalized, we get a unsafe domain string. This is gonna return a string and Boolean, and here we loop through it, and it will check the code point. If the code point is bigger than 127, that means it's non-ASCII, and here I'm gonna shift one character ahead. and eventually I'm going to return it. So a few other things. So I need to introduce this right before the register happen. So let's just define another domain and error here and start calling our normalize function with the domain that is given by the user. Now the first thing is, if I'm going to check if there is any error, that means it contains some Unicode characters, I'm going to return false. And if it contains that domain, that, yeah, return false. I may not even need this else here, so you simply go here and yeah. So if I have an error, means there is a Unicode character there, return false. If that domain name exists in the list of my domains, return false, otherwise I will add it. The other thing here, I think this should be good to go if there is no other thing. Let's just build it up. Make build. Right, so we have two. Obviously here we didn't declare. Try it again. Seems to be passing. Let's just run our usability tests. Passed, perfect. Let's run our security test. Perfect. Now we managed to cater for all those security tests. Let's head back to the browser. It seems like we ran out of the time to fix this bug. Let's just try again. Hit play again. And now go back to the terminal. Git add, git commit -m the amazing fix, well, fees, and git push. Perfect. Go back to the terminal. Now we have our commit sitting there and hit test. And we hope that we have catered for all the cases. And hopefully this will pass the security tests for us. Test passed. Perfect. Congratulations. We have passed this test. So just to recap, by the way, let me also show you the other terminal that we had. Yeah, there are some dependencies errors there as well when we had opened the OWASP dependency checker. So let's just recap. The first thing we want to do is obviously check the dependencies. If there is any outdated dependencies there, we want to cut it out. Some of those dependencies are indirect. So that means that we kind of relying on whoever is a maintainer of that dependency to fix that up. Now the other thing that we need to do here is that we can run any SaaS tool. In this example, we run semgrep. These tools are good to pick up low-hanging fruit most of the time. As we could see, the tool wasn't able to pick up that obvious security issue there. And then the next step is to effectively learn more about the code base and what does this code do, what is the functionality. And this is a part that the better you understand the code, the better you understand the semantic of the code, the better you can come up with different ways or rare edge cases that someone may enter. Now, in our case, we didn't, we identified a case where that what the program it does in a string matching is not being normalized. So we had a situation where two values are being checked, but these two values are not in the same context. And in order to address that, we introduce a normalizer. The other thing we have done was that we updated rather than we enter those edge case scenarios, case folding, Unicode confusable as an input, we end up formulate them as a unit test. So these tests will be always with us anywhere that we go. And eventually we introduce a normalizer. And a normalizer, it did two things. The first thing was it will check, it went through the input character by character, and if it identify a character is bigger than the code point of that character is bigger than 127, it considered as a non-ASCII, and that will return false. Otherwise, it will just do a case folding and it turn everything into the lowercase before returning it that's back. So a takeaway would be here, anytime you find in a code base that it does a degree of a string matching, and a string matching sometimes is quite tricky to find out. It's not as simple as this example here. Always check that if this string matching, if these two values that are being checked are within the same context, the same format, so that the string matching is comparing two things in the same context. Other than that, if you have any questions, you can now post it in a live chat. Otherwise, you can, like always, head to our Discuss platform and ask your question. And I do recommend to solve this challenge on your own and see how you go. And I think we can conclude this for now, and let's come back later in our future workshop with a different and interesting topic. Happy fixing.